Hello, good morning. Welcome to the lecture session on elements of mechanical engineering. Myself Anil Kumar MM. I am working as an assistant professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. In this session, we are going to know about the joining process. What I mean by joining process? In the day-to-day life, we are using the various products. Okay, we are using the various products in our day-to-day life. Those products are fabricated by the two or more products, okay, that can be produced by the joining two or more products. For example, machineries, automobiles, refrigerator, computers, okay, these products, it cannot be produced by a single component, but by assembling of two or more components that will be joined together and to make into a single component. That process we can call it as the joining process. For one of the example for the joining process means this is the duster, okay, it is made up of two parts, okay, this is a wooden frame and that will be joined by the cloth, the different types of cloth, okay, that can be joined with the help of the glue, okay, so it can make into a single component. That is the example for the joining process. Whatever the products we are using in our day-to-day life, those products are fabricated or joined by the assembling of two or more products. That process we can call it as the joining. So joining is nothing but assembling or the joining of two or more or assembling of two or more components and make into a single component. That process we can call it as the joining process. This joining process is classified into two types. One is the permanent joining process and another one is the temporary joining process. What I mean by permanent joining? The name itself, it is saying the joint is permanent. Okay, the joint is permanent. It is called as permanent joining. Once you have to join, it is difficult to separate. If you are going to separate that part, means it will damages the original shape. Okay, this is a temporary joint. You can easily to separate these two parts. Okay, but in the permanent joint, the joint is permanent. If you are going to separate, means it will damages the surface or it loses its original shape. That is called as permanent joint. The joint is permanent. Example for the permanent joint, that is the welding, soldering and then the brazing. Okay, next coming to the temporary joint. The joint is temporary. Okay, the joint is temporary. You can easy to separate without damaging the surface or without losing its original shape. We can easy to separate. That type of joint we can call it as the temporary joint. Example for the temporary joint, that is a mechanical fasteners like nut and bolt. With help of the nut and bolt we can join the two components, or you can with help of the screws. Okay, these are the example for the temporary joint. Okay, joining is nothing but the assembling of two or more components and make into a single component. Okay, that process we can call it as the joining process. This joining process is classified into two types. One is permanent joint and the other one is a temporary joint. Permanent joint is nothing but the joint is permanent. It is difficult to separate. If you are going to separate, means it will damages the original shape. Example for the permanent joint, that is the welding, soldering and then the brazing. And the temporary joint, the joint is temporary, that can easy to separate. Once you can join, that can be easy to separate without damaging the original surface. Okay, that is called as the temporary joint. Example for the temporary joint, that is a nut and bolt and then the screws. Okay, next coming to the syllabus, they have mentioned only the welding, soldering and brazing. Okay, so now let us discuss one by one what is welding and what is soldering and then the brazing. Okay, coming to the welding process, what I mean by welding, all of you know the word, the welding. Okay, so welding, it is nothing but it is a joining process. Okay, welding, it is one of the type of joining process and it is a permanent joining process. Okay, so welding, it is a joining process in which the two material, it can be joined with the help of the heat. Okay, the two workpiece to be joined by the heat and with or without the application of the pressure, and the with or without the application of the filler material, we can join the two metal pieces. That process we can call it as the welding. Okay, welding is nothing but joining two or more similar or dissimilar materials. We can join the similar materials, I mean same composition, that is cast iron, like that we can join, or dissimilar materials, cast iron, steel. Okay, different compositions materials also can be joined by the welding process. Okay, welding, it is a joining of two similar or dissimilar materials with the application of heat and with or without the application of the pressure and with or without application of the pressure and with or without application of the filler material, we can join the two metal pieces. That process we can call it as the welding. Okay, so during welding the heat is must. Okay, if you are going to do the any welding process, the heat is must, but the filler material and the pressure is optional. Okay, few of the welding process they are using the external pressure to join the two metal pieces along with the heat, and few of the welding process they are using the filler material, that means additional material to fill the gap between the metal pieces along with the heat. So the pressure and filler material are optional and heat is must. Okay, if you are going to do the welding means heat is must. So welding, it is a joining of two similar or dissimilar materials with the application of the heat and with or without application of the pressure and with or without application of the filler material, we can join the two metal pieces. That process we can call it as the welding. Okay, in the welding the various heat resources will be used. The heat sources for the welding process is, one is the electric arc. Electric arc is used as the heat source, or we can use the resistance. Okay, resistance of the current flow. Okay, due to so we can generate the heat, or sometimes the friction, due to that friction the heat will be generated, or sometimes the hot gases, the gas flame is used as a heat sources. Okay, these are the heat sources is used in the welding. Okay, so welding is nothing but joining of two or more similar or dissimilar materials. Okay, with the application of the heat and with or without application of the external pressure and with or without application of the filler material, we can join the two metal pieces. That process we can call it as the welding. Okay, this welding process is further classified into two types. One is pressure welding, another one is the fusion welding. Okay, this pressure welding, it is also called as the plastic welding, and fusion welding, it is also called as non-pressure welding. Okay, now let us discuss one by one what is pressure welding and what is non-pressure welding. Pressure welding, nothing but it is a joining process, or it is a welding process. The two metal pieces to be joined are heated into a plastic state. Plastic state is nothing but it is a semi-solid state. That means the below the melting temperature of the base metal. Okay, this is the base metal. Okay, the melting temperature is, this is the mild steel. The melting temperature is around 1500 degrees centigrade. But we are heating the edges of the two metal pieces below the melting temperature. If the melting temperature is 1500, just we are heating around 1300 or 1400 degrees centigrade. Okay, so just we are heating the metal into the plastic state and then applying the external pressure, are forced the two workpieces together with help of the external pressure, and without using the filler material we can join the two metal pieces. That is called as pressure welding. Okay, pressure welding means we are applying the external pressure along with the heat. That type of welding we can call it as pressure welding process. Example for the pressure welding, that is a resistance welding and forge welding. Okay, next coming to the fusion welding. Fusion welding, it is also called as the non-pressure welding. The name itself says it is a non-pressure. Here we are not using any external pressure. So in the fusion welding process, the two metals to be joined are heated into a molten state or liquid state. That means above the melting temperature of the base metal. Just we are heating the edges of the two metal pieces into the molten state, and then are adding the filler material to fill the gap between the two metal pieces, and upon cooling we will get the strong joint. That is called as the fusion welding process. Example for the fusion welding, there is the arc welding, thermite welding, and then the gas welding process. Okay, so the welding, it is classified into two types. One is pressure and fusion welding. Pressure welding, just we are heating the edges of the two metal pieces into the plastic state, and then we are applying the external pressure, or forced together with help of the external pressure without using the filler material. Here we are not using any filler material, but instead of that we are using the external pressure. The external pressure is used to join the two metal pieces. That process we can call it as pressure welding. Example, that is the forge welding and then the resistance welding. Coming to the fusion welding. In the fusion welding process, the joining of two metal pieces is heated into a molten state above the melting temperature of the base metal, okay, and then we are adding the filler material without using any external pressure. We can form the joint. That type of welding you can call it as the fusion welding. Here we are not using any external pressure, but instead of that the filler material is used. Okay, so example for the fusion welding, that is thermite welding, arc welding, and then the gas welding process. Okay, that is the classification of the welding. Coming to the advantages, the welding joints are very strong. Okay, the strong joint will be obtained compared to the base metal. The joint strength is stronger. Okay, and the portable welding machines are available, so we can easy to carry away in the remote location. Okay, the portable welding machines are available, and it is a fast fabrication process. You can easily weld. Okay, and it is a fast fabrication process, and the welding equipments are not very costly. It is economical and economical process. Okay, and both similar and dissimilar metals can be joined. You can join the same metals, or different metals metals can be joined by welding, and material with different compositions. Okay, the material with different compositions can also welded, and most of the complex shapes is difficult for some other manufacturing process like casting or machining. That complex shapes can be easily produced by using the welding process. Okay, these are the advantages of the welding process. Coming to the disadvantages, during welding it releases the harmful radiations and fumes. So harmful radiations and fumes will be produced during the welding, so care should be taken, and safety precautions should be taken during the welding, because the high temperature will be involved. Okay, and the internal stresses will be developed during the welding process, and high temperature will be involved during the welding process. So for that, so there is a changes in the microstructure of the material of the base metal. So if the microstructure changes, means the properties of the material will be changed. Okay, and care should be taken, and the skilled workers will be required for producing the good solid joint. Okay, so these are the disadvantages of the welding. Okay, coming to the applications, the welding is more extensively used in the fabrication of the bodies like automobile parts and aircraft industries, refrigeration industries, air conditioner industries. That can be extensively used, and also it is used in fabrication of the pressure vessels, and tanks can be manufactured by using the welding, and also used in the construction work. Okay, but for heavy supporting structures that can be manufactured like building, bridges. So the welding will be used, and also it is used in repair work. Okay, and then manufacturing of the furnitures. So the welding is used. Okay, these are the applications of the welding. Okay, next we will move on to the types of welding. One is the first one, that is the electric arc welding. Okay, before going to know about the arc welding, first let us know what are the parameters will be used in the welding process. Okay, some of the parameters will be used in the welding process. Those are, one is the base metal. What do you mean by base metal? This is the base metal. Base metal is nothing but it is a material which we are going to be joined. Okay, that is called as base metal. Base metal is nothing but it is a material which we are going to be joined. That is called as base metal. Okay, that is one of the term. Okay, this is the workpiece. Base metal is nothing but it is a workpiece which we are going to be joined. That is called as base metal. Next, weld bead. Weld bead is nothing but it is a material. It is deposited during the welding process. Okay, you can see here. This is the weld bead. Okay, so it is a material which deposited during the welding process. This material looks like a separate material. Okay, that is the weld bead. Okay, this is the weld bead. It is it's look like a separate material. Okay, it is the material will be deposited during the welding process. That is called as weld bead. Okay, this is one of the term used in the welding. Next is a filler material. Filler material is nothing but it is a material used for the welding process. It is used to fill the gap between the two metal pieces. That means it will provide the additional material to fill the gap between the two metal pieces. Okay, initially you have to position the two workpieces with the suitable gap. That gap is filled by the filler material. Okay, so filler material means it is a metallic rod used to fill the gap between the two metal pieces. Okay, that is one of the term used in the welding. Next, electric arc. Electric arc means it is electrical discharge. Okay, it is an electrical discharge. Okay, that is called electric arc. Okay, it transforms the electrical energy into heat energy. Okay, so this electric arc will be discharged between the two conducting material, like one of the electrode and another workpiece material. In that gap, the electric arc will be discharged. That arc temperature will be very high. Due to high temperature, it melts the filler material as well as the edges of the two metal pieces. So the arc means it is a electric discharges. It transforms that electrical energy into heat energy. Okay. Next, coming to the flux. Flux means it is a material, it is coated on the surface of the electrode or the filler material. This is the filler material and the flux is coated over the electrode. Okay, this flux is for protect the molten metal from the oxidation. Okay, it form the gaseous shield and protect the molten metal from the oxidation. Okay, that is the function of the flux. Next, oxidation. Okay, the molten metal. Okay, during welding the high heat will be involved. So due to the high temperature, the edges of the two metal pieces get melted. So this molten metal absorbs the oxygen from the atmosphere and it forms oxides. Okay, once the oxide is formed, so the defects will be takes place in the welding joint. Okay, so oxidation is nothing but the molten metal is absorb the oxygen from the atmosphere or other gases from the atmosphere and it forms oxides. That is called as oxidation. Okay, and slag, it is a material, it's react with the impurities is present on the molten metal or flux. Okay, the flux will react with the impurities and it forms the slag, and this slag is floating at the top of the molten metal, and also it prevents the molten metal from the atmosphere. Okay, these are the terms used in the welding process. Okay, now let us discuss what I mean by arc welding process. In that arc welding process, the high intensity of the electric arc is used for the welding. Okay, the electric arc is used as a heat source. That electric arc is generated by the two conducting material, one is the electrode and then the workpiece. Okay, this electrode is connected to the electrode holder and workpiece is connected and that holder is connected to the negative terminal of the power source and the workpiece is connected to the positive terminal of the power source. Okay, so electrode the electric arc is nothing but it is the stream of electrons continuously stuck in between the gap of the electrode and the workpiece material. So initially the electrode is connected to the negative terminal of the power source and then the workpiece is connected to the positive terminal of the power source. So you have to brought the electrode closer to the workpiece surfaces and touch to the workpiece surface and separate it by a small gap. That gap is around 2 to 4 mm. You have to maintain the arc gap is around 2 to 4 mm. Okay, in that gap the electric arc will be stuck. Okay, electric arc will be generated. Okay, so that electric arc temperature will be very high, so that is around 4,000 or 5,000 to 6,000 degrees centigrade. 6,000 degrees centigrade. Due to high temperature, it melts the edges of the two metal pieces as well as the electrode, and this molten electrode is combined with the molten workpiece material and allow for solidification. We will get the strong solid joint. Okay, that is the principle of the electric arc welding. Okay, now let us discuss what is the working of the electric arc welding. Okay, here this is the workpiece material which we are going to be joined. Okay, this is the workpiece material and this is the electrode and the flux is coated over the electrode, and this electrode is connected to the electrode holder and this electrode holder is connected to the negative terminal of the power source and the workpiece is connected to the positive terminal of the power source. Okay, initially we have to take the two metal pieces which we are going to be joined and cleaned it. Okay, remove the dust particles, grease or whatever the impurities present on the surface, that will be removed and positioned it with the suitable gap. Okay, first you have to take the two metal pieces which we are going to be joined and then cleaned it and remove the dust particles or grease, whatever or oil, whatever present on the surfaces, and then positioned with the suitable gap. Okay, and next take the electrode, the flux coated electrode, and this electrode is connected to the electrode holder and this holder is connected to the negative terminal of the power source, and this workpiece is connected to the positive terminal of the power source. Okay, next switch on the power. The suitable current and voltage will be supplied through the electrode and the workpiece material. Okay, the suitable current and voltage will be supplied through the electrode and the workpiece material. Okay, here AC or DC power source will be used. Okay, and initially you have to brought the electrode closer to the workpiece surfaces and touch it, and momentarily it's separated by a small gap. Okay, when you maintain that small gap, at that time the electric arc will be struck between the gap of the electrode and the workpiece material. In that gap the electric arc will be generated. Okay, the electric arc will be struck between the gap of the electrode and the workpiece material. Okay, so the distance between the electrode and the workpiece gap is around 2 to 4 mm. In that gap the electric arc will be generated. So this arc temperature will be very high. It is around 5,000 to 6,000 degrees centigrade. Due to high temperature the electrode will be melted. At the same time the edges of the two metal pieces is also melted. Okay, so because of high temperature the edges of the two metal pieces get melted. At the same time, the flux coated electrode is also melted. Okay, this molten electrode is combined with the molten workpiece material. Okay, this molten electrode is combined with the molten workpiece material. Upon solidifying, we will get the strong solid joint. Okay, and then whatever the flux is coated on the electrode, that is also melted, and it forms the gaseous shield, and it protects the molten metal from the atmosphere. That's why the flux is used. Okay, this main function of the flux means it forms the gaseous shield and it protects the molten metal from the atmosphere. Otherwise, this molten metal, it absorbs the oxygen from the atmosphere and it forms the oxide. Once the oxide is formed, means the defects will be, the joint will be weaker, or defects will be takes place in the welding joint. To prevent that, the flux will be used. Okay, this flux will be melted and it forms the gaseous shield and protect the molten metal from the atmosphere. Okay, that is the working principle of the electric arc welding. The electric arc is used as the heat source in the electric arc welding process. Okay, the electric arc will be, high intensity of electric arc is used to melt the edges of the metal pieces as well as the electrode. Okay, and here the flux is coated on the electrode, it forms a gaseous shield and it protects the molten metal from the atmosphere. Okay, and AC or DC power source will be supplied through the electrode and the workpiece material, and electrode is connected to the negative terminal of the power source and the workpiece is connected to the positive terminal of the power source. Okay, that is the working principle of the electric arc welding process. Okay, next we will move on to next type of welding process, that is tungsten inert gas welding process. It is popularly known as the TIG welding process. Okay, in the tungsten inert gas welding process, the workpiece to be joined by the heat, it is generated by the electric arc. The electric arc will be stuck between the non-consumable tungsten electrode and the workpiece material. Okay, in this process they are using the non-consumable electrode, that is made up of tungsten. Okay, here we are using the consumable electrode. The electrode is consumed during the welding. The electrode is also melted because this electrode is made up of same as the base metal. The electrode is melted. Okay, and the workpiece edges also melted. This molten electrode combined with the workpiece metal and it forms the joint. But in the tungsten inert gas welding process, the non-consumable electrode is used. Okay, this non-consumable electrode, it is made up of tungsten. Okay, that's why it is named as tungsten inert gas welding process. And this process we are not using any flux material. Instead of that, we are using the inert gases. Okay, the commonly used inert gases are, that is helium or argon gas will be used. This inert gases, it forms the gaseous shield and it protect the molten metal from the atmosphere. Okay. In the tungsten inert gas welding process, the two workpieces will be joined by the heat. It is generated by the electric arc. The electric arc will be stuck between the non-consumable tungsten electrode and the workpiece material in the presence of the inert gases, and the separate filler material will be added in the welding process. Okay, that is the work principle of the tungsten inert gas welding process. In this process, it consists of the welding torch. Okay, and the tungsten electrode is rigidly fixed into the welding torch, and the tip of the welding torch looks like a nozzle. Okay, and the shielding gas cylinder will be connected to the welding torch for supplying the inert gases. Okay, this is a gas cylinder. Okay, it contains the helium or argon gas, and the regulator will be provided to control the flow rate of the gases. Okay, and this cylinder is connected to the welding torch. Okay, through the torch handle. Okay, this is a torch handle. Through the torch handle, it is connected to the shielding cylinder, and the tip of the welding torch looks like a nozzle. Okay, and this is a non-consumable tungsten electrode that is rigidly connected, fixed to the welding torch. Okay, and this is the workpiece material, and the welding torch or electrode is connected to the negative terminal of the power source, and the workpiece is connected to the positive terminal of the power source, and AC or DC power source will be supplied into the welding area. Okay, here AC is preferred for the welding of aluminum and magnesium alloys, and the DC will be preferred for the welding the stainless steel material and copper alloys, nickel alloys that can be welded by using the DC power source. Okay, coming to the working process. Initially, had to take the two metal pieces which we are going to be joined or cleaned it. Just remove the dust particles, oil or grease, whatever present on the surfaces. Just you have to remove it, and then positioned it with the suitable gap. Okay, and then the suitable welding current the suitable welding current and voltage will be supplied through the electrode and the workpiece material. At the same time, the inert gases also supplied. Okay, just you have to turn on the power source and then the inert gas cylinder. Okay, when you supply the electric current, at that time the electric arc will, okay, so initially you have to touch the tip of the electrode to the workpiece surfaces and momentarily separated by a small gap. That gap is around 1.5 to 3 mm. We have to maintain the gap between the electrode and the workpiece material is around 1.5 to 3 mm gap. Okay, initially you have to touch the electrode to the workpiece surfaces and then separate it. And when you separate it, that time the electric arc will be struck in between the gap of the electrode and the workpiece material. Okay, when you separate it, at that time the electric arc will be struck or stabilized in between the gap of the electrode and the workpiece material. This arc temperature will be very high. Due to high temperature, it melts the edges of the metal pieces. Okay, at the same time you add the filler material, that means additional material. This filler material is also melted. This molten filler material is combined with the molten workpiece material and allow for cooling. You will get the strong solid joint. Okay, at the same time you have to supply the inert gases to the welding area. So this inert gases, it forms the gaseous shield. Okay, this forms the gaseous shield and it protects the molten metal from the atmosphere. Okay, otherwise this molten metal will absorb the oxygen from the atmosphere, it forms the oxides. So to prevent that molten metal, the inert gases will be supplied. So this inert gases, it forms the gaseous shield and it protects the molten metal from the atmosphere. Okay, that is the working principle of the tungsten inert gas welding. Here in this process, the tungsten electrode is used and it is a non-consumable electrode. It is not consumed during the welding, only it stabilizes the electric arc. Okay, it generates the electric arc, and here we are not using any flux. Instead of that, we are using the inert gases. The commonly used inert gases are argon or helium gas will be used. This gas will form the gaseous shield and it protects the molten metal from the atmosphere. Working, initially I had to take the two metal pieces and cleaned it and positioned it with the suitable gap. Okay, and then the suitable current and voltage will be supplied through the electrode and the workpiece material, and at the same time you have to separate the inert gases from the cylinder to the welding torch. Okay, and when you supply the electric current, you have to brought the electrode to the workpiece surfaces and touch it and separate it by a suitable gap. That gap is around 1.5 to 3 mm. In that gap, the electric arc will be stabilized. So the electric arc will be struck between the gap of the workpiece as well as the electrode. Okay, so this arc temperature will be very high. Due to high temperature, the edges of the two metal pieces get melted. At the same time, you have to add the filler material, okay, manually, and this filler material is also melted. This molten filler material is combined with the molten workpiece material and allow for solidifying or cooling. We will get the strong solid joint. At the same time, you have to supply the inert gases to the welding area. This inert gases, it forms the gaseous shield and protect the molten metal from the atmosphere. Okay, that is the working principle of the TIG welding. Okay, the difference between arc welding and TIG welding is, here the consumable electrode is used and the flux is coating over the electrode, and this flux forms the gaseous shield and protect the molten metal from the atmosphere. Okay, and here the electrode is act as a filler material. Okay, this electrode, and here we are using the consumable electrode, but here the separate filler material will be added manually and the non-consumable electrode is used, that is made up of tungsten, and here we are not using any flux. Instead of that, we are supplying the inert gases. That inert gases, it form the gaseous shield and protect the molten metal from the atmosphere. Okay, the main advantages of the tungsten inert gas welding process is, this process is suitable for only the thin workpiece material. Okay, less than 4 mm thickness of the workpiece material can be welded. Okay, and the clear vision of the electric arc, so that will helps to the operator to do the welding. Okay, clear visibility of the electric arc, and then the strong and high quality joints will be obtained by using the TIG welding process, and here we are not using any flux, so there is no slag formation in this process. Okay, so the clean welding joint will be formed in the tungsten inert gas welding process. Coming to the disadvantages, it is difficult welding process compared to all other welding processes. Okay, the process is quite difficult, and then it is a slower process. It takes more time to do the welding. Okay, and highly skilled operators will be required to operate the tungsten inert gas welding process. and it is not suitable for the thick metal. Okay, thick workpiece is difficult to weld. Okay, it is not suitable for the thick workpiece material. Okay, it is suitable only for the thin metal pieces. Okay, less than 4 mm material can be welded by using the tungsten inert gas welding process. And coming to the applications, it can be extensively used in aerospace industries. Okay, that is one of the primary application of the tungsten inert gas. It is extensively used in aerospace industries as well as the air conditioning industries and refrigeration industries. This type of welding is used, and also it is used in welding stainless steel material. Okay, and copper alloys, nickel alloys can be welded by using the tungsten inert gas welding process. Okay, in the next session we are going to discuss the another type of the welding process, like metal inert gas welding process, metal inert arc welding process, and the gas welding process. Okay, thank you.